Hey, let's do this question. Counts of small numbers after self. So you're given an array and you want to return an array of the same size where each number is a count of how many numbers are smaller than the corresponding number in the given array to the right of it. So for example, here you have 5. How many numbers smaller than 5 to the right? Well, there's 2. So you have 2 in the result. For this one, you have 1 smaller, that's 1, and so on. Okay. So you could, by brute force, you could do it for this number, go through and count how many numbers less than 5. For this number, go through and count how many numbers less than 1. So that will be n squared. But n squared is too slow because this is 10 to the power 5. What can we do? Well, if we go from the right to the left for this example, and we keep a sorted array, say 1 initially, and then we're up to the second element here, and we find out where this number would go in the sorted array. Well, it would go here, right? That's the first index, and this is a sorted array. So I know that the index here is actually the number of elements less than 6. Then I move the I across. Where would 2 go in this sorted array? Well, it would go in between these two. So the number of elements less than 2 would be 1. Okay, that's the index. And then go down here. 5 would go in between here. So then I know there are 2 elements less than 5. Right, so that would work. The problem is there is no data structure that can insert a number in constant time or log n and still know in constant time what the index of that number is, or how many numbers to the left of it. So that's kind of a problem. Well, what if we actually have a giant array containing all possible numbers? So let's say that all possible numbers, let's say 4, 2, 3, 1, are 1, 2, 3, 4, and we initialize this giant array to 0. This is the count of each number, and this is the number. So let's say I'm starting at the right of this array, and then I see a 1, so I increment the count of 1 from 0 to 1. Then I move the I down to 3, so I increment the count of 3 to here. And then I query this range here. What's the sum of this range here? Well, it's 1, and that will be the answer. And then I add that to the result. Alright, so that would work. But to get the sum of this range, you will need like a range tree. Right, so that's what we're going to do. And I've went in detail how to create a range tree in a previous video, so we can skip that logic mainly. Maybe I'll briefly go through it. The first step is to figure out creating this tree is figuring out how large it is. So we need an array for all possible number values. So you have from negative 10 to the power 4 to positive 10 to the power 4. Right, so that's how many numbers is that? Let's call that static int const int max n 2e4 plus 1. So that's from the range negative 10 to the power 4 to 0, and then 0 to 10 to the power 4. Alright, so that plus 1 is for the 0. Alright, so this is the range of all possible numbers, but because I want to create a range tree over this, I need something more than double this and make it a power of 2. So let's call that tree, the tree size, as tree n. So 2e4 plus 1 is 20,001. I need something more than 40,001. So that'll be 2 to the power 16, 65,536. So let's do 2. 1 bit shifted 16 times to the left. Also, because I want the index to match the actual value, like here, because I have negative numbers, when I use the number, I actually want to make it positive by adding 10 to the power 4 to it. So let's make it that a const. So 1e4, an update function to update the range tree. Now for the actual algorithm, what we could do is keep track of an answer of size nums.size. So auto answer is equal to this. Let's also make the tree, I haven't done that yet, so it's int has the size max tree n, and that's initialized to 0. You want to return the answer eventually, but before that you want to go through starting from nums.size -1, so the last element, all the way up to down to 0. Keep decrementing until then, and then we're going to set the answer at the current index to be equal to the query value, so querying from 0 to nums at I, but we want to add h to make it positive. Here we want to update the tree with the current number, and the rest are defaults. Yep, so that hopefully works out for us. Query is of type void, so I actually want to turn it int. One other thing, it should be end minus the start, because n is larger. Okay, so that's 0. Let's test the given test case. Cool, let's submit that. Had a bunch of runtime errors when I did this. Reason because I didn't set this max n properly. I set max n here to be tree n, which is way too large. It should be max n. Yeah, and that works quite well. Thanks for watching. Like and subscribe. If you have any questions, leave it in the comments below, and I'll see you in the next video.